Okay, let's unpack this. Have you ever stopped to think about the invisible digital architecture that underpins massive communication networks?
Right.
We're talking beyond your home Wi-Fi.
Hmm.
Think about the systems that keep large-scale radio communications, like, for emergency services or huge industrial operations, running seamlessly.
Yeah, the really critical stuff.
Exactly. Today, we're taking a deep dive into the brain of one such system, Motorola's Zone Configuration Manager, or ZCM.
Hmm.
This isn't just a piece of software. It's really the central nervous system for an entire radio network, orchestrating every single piece.
And what's fascinating here, I think, is that our deep dive is based on, well, just a single source, a user manual from May 2012 for this ZCM software.
Just the manual.
Just the manual. But within its pages, you uncover this surprisingly intricate world, managing everything from, sprawling radio sites right down to individual microphones.
Mm-hmm.
So our mission today is to pull out those essential nuggets, sort of connect them to the bigger picture, and show you just how detailed, how powerful, and frankly, how vital this kind of configuration tool really is.
Okay, so let's start at the beginning then. What exactly is the ZCM?
Well, fundamentally, it's a core component designed specifically to manage Motorola's professional Tetra IP radio system.
Tetra IP, right. And that covers a range of systems.
It does. The manual mentions several versions: Tetra IP Scalable 8.0, Tetra IP Compact 8.0, even Scalable Tetra IP 8.0 again, and Tetra IP Micro or Light 2.0.
So it scales from huge networks down to smaller ones.
Exactly. And the insight there is how one tool manages that whole family, providing consistency for the engineers.
Makes sense.
And fundamentally, its job is to be the master control for all the operational parameters of the network's equipment.
Okay, equipment parameters. And you mentioned zones within these systems.
Right. Think of a zone as a distinct, managed segment of the network. Each zone gets its own ZCM instance to manage its specific infrastructure. And that infrastructure can be pretty extensive, up to 100 radio sites, for example.
100 sites per zone.
Potentially, yeah. And when we say infrastructure, we mean the physical gear-based radios, the consoles dispatchers use, all that.
Got it. So ZCM handles a whole zone. But how does it fit into the bigger picture, like Motorola's whole network management suite?
That's a crucial point. The ZCM isn't operating in isolation. It's an integral part of the broader Motorola Private Network Management Suite, the PRNM suite.
PRNM, right?
It's one piece of a much larger puzzle, which, raises an important question.
Yeah, how does it interact with other tools in that suite? Like, I think you mentioned TESS, Motorola Tetra BTS service software.
Exactly, TESS. You'd think they just, work together smoothly.
But is there a hierarchy? What if you try to change the same setting in both places?
That's where it gets really interesting. For certain critical settings, ZCM is basically the boss.
The boss.
Yeah, it holds the master blueprint for what they call manager-owned parameter.
Manager-owned, okay.
So think of it like this. If you make a change to one of those parameters using TESS, ZCM will actually detect that difference.
And override it.
And overwrite it. To ensure everything stays synchronized with its central database, it enforces absolute consistency for those key settings.
Wow.
But then for other settings, agent-owned parameters, the individual radio or device itself is the boss, holding its own master copy.
So some central control, some local flexibility?
Precisely. And that hierarchical control is really paramount for maintaining system integrity across the whole network. Prevents conflicting settings that could, cause major problems.
That's a really clever way to ensure consistency, but allow some local variation. Okay, so once you're actually using the ZCM, what's it like? What's the interface look like?
Well, when you open it up, the main window has, familiar Windows features: title bar, split bar, minimize, maximize, all that.
Sinister.
Yeah. But the key elements you interact with are the navigation pane on one side, which shows a hierarchy of all the configurable objects.
Like a tree view.
Exactly, like
Okay.
a tree view. And the contents pane on the other side, where the actual settings and records for the selected object are displayed.
Okay. And how do you navigate that tree?
So ZCM offers two main ways, two paradigms. There's class-based navigation, CBN,
CBN.
that shows you object types in a fixed structure, like you'd see all zone objects grouped together or all site objects.
Sort of a category view.
Right. Then there's instance-based navigation, IBN.
IBM.
And that one is more like Windows Explorer or File Explorer. It reflects the actual configuration of devices and their sub-devices in your live system.
So it shows the real hierarchy as it's set up.
Exactly. But there's a critical difference with IBN. If you delete a container object, like a site,
Oh.
it automatically deletes everything inside that container too. All the radios, channels, everything associated with it.
Okay, so you need to be careful with IBM deletes. Understood. How does it make this hierarchy easy to grasp visually? Are there icons or something?
Yeah, visual cues are essential. Different icons represent different objects. You might see a simple folder for a top-level class.
Mm-hmm.
But then there are special icons for specific configurable things, like a distinct symbol for a zone or maybe a slot. You also get category icons for record types, like server record or site record.
Okay.
And importantly, if you see an object that's dimmed or grayed out,
Means you can't touch it.
exactly, it's an immediate signal that you don't have the necessary access rights to configure that particular object.
That's helpful. Does it have other windows or tools besides the main navigation?
Oh, yeah. Beyond the main interface, ZCM gives you access to several secondary windows, things like security group
Some
selection,
permissions?
right, also diagnostics, report generation, a find function, and very specific configuration windows. It really shows the breadth of functionality. It's not just setting parameters, it's a whole management suite.
Okay, so ZCM is clearly powerful, very structured. But let's get down to the brass tacks. What kind of specific objects and settings are we talking about here? What does this all mean for the actual network?
Right, the detail. It truly is an incredible level. We can sort of group these configurable objects into a few key areas.
Got it.
First, you've got the core network components, the real brains of the operation.
The brains, yeah. Like what?
Well, the zone object itself manages core attributes for the zone. And interestingly, you can't create or delete a zone after the initial installation.
Oh, so they're fundamental building blocks.
Exactly. Predefined segments. Same goes for the zone controller. Manages controller attributes, can be standalone or integrated, and includes things like network time protocol, NTP configuration.
To keep all the clocks synchronized.
Precisely. Critical for logging and event correlation.
Makes sense. What else in the core?
There's the air traffic router, which configures things like statistics collection and airtime usage data, diagnostics for that too.
Tracking how busy the airwaves are.
Yeah. Then the alias server. Think of this as the network's address book and sort of traffic director for user logins. It handles book on, log on, forwarding.
So user authentication and message routing.
Right. And crucially, you can configure where it sits in the DMZ, that's the demilitarized zone.
Like a buffer network?
Yeah, or the CNE, the core network environment, which is the secure heart, or even a customized subnet. Shows you the security flexibility.
Okay. Data services.
Yep, for that, you configure the Packet Data Gateway, PDG, and the Short Data Router, SDR. These enable features like store and forward for messages, MS to group calls. Often these are license-controlled features.
Ah, so you enable what you pay for.
Pretty much. And only one SDR per zone. Then there's the Radio Network Gateway, RNG, just identifies that gateway, and level of service.
I thought it's important.
It really is. This configures availability for things like interconnect calls, how many simultaneous calls, max busy delay, tied to something called shared service. It directly impacts performance, especially in busy times.
Wow, okay. So that covers the core network. But what about the people using it? The dispatchers, the operators? How does ZCM manage their interface?
Right, the console operations. You configure a console site, which is basically a collection of dispatch consoles and maybe logging servers at one location. You give it an ID, aliases.
Standard setup stuff.
Yeah, but then you get into the application platform within that site, which hosts the actual dispatch and archiving interface server apps.
Okay.
And then you configure the dispatch application itself. Could be for different console types, like the MCC 7500 series.
And this is where the audio details come in.
This is where it gets fascinatingly granular. You can configure things like send AGC automatic gain control for the microphones.
So the volume adjusts automatically. No shouting needed.
Exactly. Helps keep everything clear. You've got echo cancellation,
Right.
even acoustic cross mute to stop feedback if consoles are physically close together.
That's smart, preventing that horrible squeal.
Right. And you configure peripherals too. Microphones, speaker, headset, foot switch, even external telephone interfaces.
Huh.
And for mics and speakers, you can set really specific audio parameters, transmission maximum levels, output levels, and dBm.
You're configuring the audio levels for individual speakers. That's incredible detail.
It is. Imagine needing that level of control to ensure clarity in an emergency dispatch center. It's vital. There are also specific applications like the Archiving Interface Server, AISA, with their own logging settings.
Okay, so the human interface is meticulously controlled. Now, the invisible part, the radio waves themselves, how does ZCM handle the RF side?
That brings us to the radio frequency, or RF infrastructure. Here, ZCM lets you configure individual EBTS sites, or NTS sites, those are the base transceiver stations or mobile telephone system sites, your radio towers, essentially.
Within the zone, right?
Within the zone, yeah. They share a pool of site IDs, 1 to 100. Then within a site, you manage individual base radios. And you configure the channels at that site. Channel ID, whether it can be a control channel if it handles packet data. And critically, at least one channel per site must be set up as the main control channel, the MCCH.
That's how radios know where to connect.
That's the anchor channel, yeah. ZCM also manages RF shared service, how the system allocates call capacity, can be table-driven or use a dynamic algorithm, DSSA, which is a purchasable option that adapts automatically.
Optimizing the use of the airwaves.
Exactly, making sure the spectrum is used efficiently. You also configure things like EBTS receivers for fault isolation.
And site-specific stuff, like for MTS.
Right, for MTS sites, you configure the type MTS 1, 2, or 4, and you might configure an auto-tuned cavity combiner, the ATCC.
What does that do?
It receives and combines signals from multiple base radios up to 5 for an MTS-4 system. Helps get strong, clear signals across the site. There's also a digital power meter, DPM, to measure antenna performance.
Wow. And what about the links connecting these sites?
Good point. There's an Ethernet site link profile object where you configure things like acceptable delay and jitter thresholds for the Ethernet connections, different profiles maybe for terrestrial links versus satellite.
So, managing the quality of the connection between sites, too. Okay, that covers the core IP stuff. But what if you need to connect to, like, the old phone network?
Yes. That's where the legacy hardware and telephony interconnect objects come in. The manual notes these are specifically for systems needing that bridge.
Bridging the old and new.
Exactly. You might have a Motorola Gold Elite Gateway, or MGG. That's an interface between circuit-based networks like traditional phone lines and the IP packet network. You can add voice cards, line cards to it.
To physically connect phone lines.
Right. Then there's the Interconnect Subsystem object, which manages the overall telephone interconnect, or TI, services to external PBX systems.
Like company's internal phone system.
Yeah, or the PSTN, the public switch telephone network, your regular landline system.
Okay. And how does the actual connection happen?
Through gateway devices. You configure MTIGs, Motorola Telephone Interconnect Gateways, or generic TIGs. These act as the gateways, doing the translation, the transcoding between the Tetra IP world and the external phone networks.
Transcoding? Changing the audio format?
Essentially, yeah. And these MTIGs can connect using different links, traditional digital phone lines called E1 links.
Common outside North America, right?
Right, high-capacity digital lines. Or they can use modern IP links. So flexible connection options. You configure details like time slots for E1 links, how many simultaneous calls are licensed for IP-based MTIGs.
Licensing again.
Always licensing. You can have up to 4 MTIGs or 8 TIGs per zone. And you define interconnect channels to select call paths, balance traffic.
And how do users actually make those calls?
Through call routes. You define the paths for radio users to dial out to the PBX or PSTN. Includes things like dialing prefixes, routing rules, maybe even call redirection.
So you program dial 9 for an outside line kind of thing.
Basically, yes, but for the radio network. There are also objects like switch, MUX, multiplexer, slot, A&B, Ambassador Electronics Bank. These manage audio routing within the zone, connecting devices like TIGs or MGEGs to specific physical slots. Very hardware-focused.
Okay, lots of detail there for tying into older systems. Finally, any other bells and whistles? Enhanced services.
Yes, under Enhanced Services, ZCM enables features beyond just basic voice. There's the Enhanced Services Platform, ESP.
What does that do?
Extends capabilities. Think location services, reporting, dynamic group management, stuff like that.
Location. Like GPS tracking.
Exactly. There's a Motolocator object specifically for storing historical GPS locations of devices.
Wow, imagine that, tracking the history of every radio's GPS coordinates.
Yeah. And there's also Unified Network Services, UNS, which provides presence knowing if a user is online, and location services for users on the Tetra IP network.
So more than just talk, it's about situational awareness.
Precisely. Knowing where your resources are and their status in real time.
That's truly an incredible amount of detail ZCM manages across so many different areas. So after all that configuration, what does a user actually do with these objects in ZCM day to day? What are the common actions?
Well, the typical actions are pretty straightforward. You're often creating new records. You can do that using system defaults, which is efficient, or by cloning an existing record, sort of like a save as function.
Makes sense. Saves time if you have similar sites or devices.
Exactly. Then, of course, you're modifying records. You can change settings on a single record, or sometimes even apply a change globally across all records of a certain type.
Modify all.
Mm,
Sounds powerful, maybe a bit dangerous.
it is powerful, yeah. And finally, deleting records, which always requires confirmation steps, naturally.
Okay, standard create, modify, delete. But this system sounds incredibly complex. What happens if someone, inevitably makes a mistake during configuration? Is there an undo button, a safety net?
Absolutely, and it's a critical one. That's where commit and rollback come in.
Commit and rollback. Okay.
Commit is the action that actually pushes your configuration changes out to the site equipment. It applies them to the live network.
Makes them real.
Makes them real, exactly. Well, let's say you've made a bunch of changes, saved them in ZCM, but you haven't hit commit yet.
Okay.
If you realize you made a mistake, rollback is your lifesaver. It lets you undo all the saved but uncommitted changes, reverting everything back to the last successfully committed state.
Ah, so it's like reverting to the last known good configuration.
Precisely. It's an absolutely vital safety net in these complex live systems. A bad configuration could have serious immediate consequences, so rollback is crucial.
That's a huge relief knowing that's built in. Beyond making changes, ZCM also sounds like it holds a ton of information.
Really?
Is it useful for just seeing what's configured, like reporting or searching?
Oh, definitely. It has built-in reporting capabilities. Users can generate reports based on specific criteria. Show me all channels configured this way, for example.
And you can export those.
Yep. Export to HTML, which is handy for sharing or documentation or auditing. And there's a find function, too. You can search for records using wildcards and different parameters.
So it's like having a super-powered search engine for your network configuration.
Pretty much, yeah. Makes it much easier to find specific settings quickly when you need them.
And what about managing the live system? Troubleshooting.
That's where the diagnostics window comes in handy. It allows authorized users to actually change the functional state of objects.
Like turn things on or off.
Exactly. You could enable or disable a specific channel, maybe restart a base radio if it seems to be having issues. It ties directly into fault management and recovery.
Okay. And you mentioned security before. How does that work?
Through security groups. These are used to filter what users can see and what they can modify within ZCM. Ensures only authorized personnel can access or change certain sensitive configurations. It's role-based access control, essentially.
That makes sense. You don't want everyone messing with the core network settings.
Definitely not.
Now, here's something you mentioned that sounded, well, unexpected. Unicode font support. Instructions for installing fonts in a radio system manual. Why is that important?
Right. It seems trivial at first glance, but think about it. This is potentially a global system. You might have operators or configuration text using different languages, different character sets, special symbols.
So displaying text consistently is key.
Absolutely critical. In mission-critical systems, misinterpreting even a single symbol or character because the font wasn't right could lead to a serious error. It underscores the incredible meticulousness needed. Ensuring consistency and preventing miscommunication, even down to the font level.
That's a truly fascinating detail. It really highlights the precision required. Okay, moving beyond the pure technical stuff, what about compliance? Other requirements?
Yeah, the manual actually touches on some important compliance aspects. It specifically mentions the European Union's WE directive waste of electrical and electronic equipment.
Oh, the crossed-out trash bin symbol.
That's the one. Its purpose is clear. Keep this electronic gear out of regular household waste. Encourages proper disposal and recycling.
Standard environmental compliance for electronics in the EU.
Yeah.
Anything else?
Yes, and this one was also quite interesting. China Management Methods, or CMM, environmental regulation.
CMM for China. What does that involve?
The document describes two logos you might see. Logo 1 means the product is clean, no excess hazardous substances. Logo 2 means it might contain some substances above the limits.
What?
But it comes with an environmental friendly use period, or EFUP. It's a number. In years.
An EFUP number, what does that signify?
It's the estimated period during which those potentially hazardous substances won't leak out or mutate in a way that causes pollution or injury under normal use.
So it's like a safe operating lifetime from an environmental perspective.
That's a good way to put it. It's a fascinating look at how environmental regulations get embedded right into the product documentation for global markets,
Yeah.
tying product design directly to ecological responsibility.
Really interesting how that becomes part of the technical spec. What about support if things go wrong?
The manual highlights the support mechanisms available. There's the EMEA Systems Support Center, ESSC, for remote technical help,
Okay.
and the Motorola Online Extranet for accessing updated manuals and documentation. And the document's own history noting editions from November 2011, March 2012, May 2012 shows it's a living thing, constantly being updated and evolved.
Right. Software like this is never truly finished. Okay, so we've taken quite a deep dive today into this zone configuration manager. It's really pulled back the curtain on the incredible detail and precision needed to manage a modern radio network.
Absolutely. From synchronizing network clocks down to the millisecond, ensuring crystal clear audio for every dispatcher, bridging old phone lines with new IP tech.
Yeah, even handling global environmental compliance details. It just exemplifies the immense power and responsibility held by the engineers keeping these critical systems running.
It really is a testament to the complexity hidden within our modern infrastructure.
And if we connect this to the bigger picture, it really makes you wonder, doesn't it? What other hidden control panels exist for the critical systems we rely on every day?
And how do their intricate designs, even the seemingly tiny details, work together to ensure reliability and safety? It's a fascinating question.
So next time you rely on a complex communication system, maybe emergency services, maybe a large utility or transport network, just consider the incredible layers of detailed work that go into its configuration.
It's far more granular, far more carefully managed than most of us probably ever imagine.
Definitely food for thought.
Huh.
Until our next deep dive, keep exploring and keep asking those big questions.